GM. YouTube telling me my bitrate is too fast. I don't know how to fix that. Okay, I'll fix it later. That's way too fast. How do I... It says... 7,000. View bitrate. Let's go. 10,000. Let's try that. Okay, we're better. Nice. Stream is healthier now. Alright, cool. Let's do it. What up, gang? How we doing? Hope we're doing well. Figuring out if I want to do more streams more often. If people like them, I will keep doing them. If y'all hate them, I won't do them. But I figured I'm doing some work on this Saturday. Girlfriend is going out with the ladies. I'm gonna do some streaming, do some coding, and if y'all want to tag along, join in the fun, feel free. We doing some signature stuff. Some signature replay prevention. It came to my attention that a lot of people don't understand a lot of EIPs that are actually prerequisites to signature replay prevention attacks. Something that I'm kind of upset I didn't go over as much in the security course. So I'm going to do that here. And then I'll probably add this to Updraft later once we're finished. I'll catch you guys all up to speed. I would like to make millions by exploiting a contract. Luca... banned for life. You're banned for life. I'm in EST. It's morning. It's not morning out here. It's like 4 p.m. But yeah, and then if I finish building my demos early, I got some Certora stuff I got to do. So I'm working on part 2 of the security course. Most of it's pretty much all done, but actually I got stuck on some new stuff that I wanted to add because that's pretty much how my life goes. I make a course and then I go, shit, I want to add more stuff. And then I go add more stuff and then make it even better. So we're going to add more stuff. Yeah. So I'm going to share screen. Hire you, please. So I'm going to share screen and then I pop out the chat here. Share screen, show you what I've done so far. Get you guys all up to speed with how we're doing, and then we'll just jump right into it. So let me pop out chat here. Oops. Can we pop out the chat, please? Pop out chat. There we go. Good. For anybody listening on Twitter, head over to YouTube. Yo, what up, Open Sense? Okay. All right, let's do this. So let me just kind of quickly show you guys where we are so far. What happens when I do this? What do y'all see? Okay, you'll see that. Okay, that's kind of annoying, but deal with it. So far, this is what we have. Basically wanted to, and then I'll probably make a video on this at some point. For signing transactions, you actually need to know how EIP-191 and EIP-712 goes. Yeah, these are going to be all of my notes that I'm going to use to teach people about these. Basically, when signing transactions, we wanted to make a way to make life easier. Actually, I even have like a little demo in the README. When signing transactions, you guys can't really see this. When signing transactions, like originally, like up in your MetaMask, like this, all right, zoom in even more. like this horrible monstrosity text would pop up. Be like, hey, you want to sign this message? Here's what you're signing. And it's like, oh, well, I have no idea what the hell that means. So it means nothing. And so we said, hey, let's come up with a standard so that when these little, hey, sign this thing comes up, like it actually looks like something that humans can read, right? So something like this. So we came up with these two EIPs, EIP-191 and EIP-712 to basically do these. To make these signatures readable. And this EIP-712 is also the key, is also the key to preventing these replay attacks, right? Because basically inside of this structured data, I'll explain that in a bit, you put all this stuff that prevents signature replay use. For example, nonces, deadlines, etc. Stuff I'll show you all in a bit. But so what I did here, and if you guys want, this is where this is located. If y'all want to see the code base here, feel free to do so. I made a couple of kind of almost like mentally stepping stones on how signatures work. So we have kind of like this thing, this contract signature verifier. We have function get signer simple. So this passes some message. We're doing a uint256 as a message. And I know it's kind of small on screen when I'm streaming. This is probably just always going to be the case. Too bad if you don't like it. Message, like the message that we want to sign. It could be a string. It could be literally anything. And then the V, R, and S. This is like some stuff that happens behind the scenes. They're just like key components of any signature. But we take this hashed message and we just use this ECR recover. It's a precompile in the EVM. It basically allows you to take any message and get who signed it with the VR and S of their signature. And it's how kind of all of Ethereum works, right? It's this like kind of math equation behind the scene. You don't really need to go too much into this, but basically, yeah, if you have a signed message, a hashed message, and the signature of the message, you can check. You can easily find who actually signed it. So with that knowledge, you can very easily make a verify signer like simple contract or function in Solidity, where we just take some message, the signature, and the expected signer, and we just get the signer and then just compare it to the we compare the actual signer to the expected signer, and boom, if they don't match, it reverts, right? So this is how signatures work at a super, super simple level, right? You take some hashed message, you take the signature of the hashed message, you recover the address, and then you just check to see if it's the address that you want, and boom, like you're good to go. That's it. Verify signer simple. So this is how signatures work super simply. Now we got to go take this and then level it up. And then I'm also seeing y'all comments here. Nice to have y'all here. Joined from OpenSense. Hello. Oh, what up? Oh, cool. Oh, what up, OpenSense peeps? Nice to see y'all. Cool. Anyways. Now that we have these kind of, this is how like signatures work. We go, okay, cool. We want to go one step further. And I have like a shit ton of notes in here that I'm probably not going to go over in this stream, but I'll give you kind of the skinny. Basically, these were cool, but again, people liked signatures, and okay, maybe I'll read a little bit of this, but wanted people to send transactions by signatures, right? And signatures have a whole, ETH transactions have a whole bunch of different components, and we basically said, hey, we can use some of these components to sign something with some of those components, and then send a transaction for somebody else. So it's like I sign a transaction, I don't send it, I give it to my buddy Bob. Bob goes, oh cool, I'm going to take your signature, I will spend the gas and send this transaction for you. Excuse me. So you can actually do that directly without functions at all, but we also wanted to do it with functions too, because if you give Bob, never mind, I'm not going to explain it right now. We wanted a way to to sign a transaction and let somebody else spend the gas to actually send it. So we came up with this thing, EIP-191. Don't worry, I will be done with the context soon, and then I'll go back to coding. This signed data standard, which is super dope, and everyone should know about it, and too many people actually don't know about it. But basically, this is the main thing that you need to remember. So we propose the following format for signed data. So all signed data, whenever we sign a transaction, it's in this format. They all have a prefix of 0x19. Why? Well, because the hex of this equates to the decimal 25, which is like kind of a random-ish number. It's highly likely that no other, encoding thing has this to start. So whenever we see this as part of like some data, we go, oh, okay, this is probably a signed bit, a signed piece of data. We give the byte version, the 1 byte version. So like what version of signed data we're using, some version specific data and data to sign. And you'll see what I mean in just a second here. So in our, and we use this, and so we basically, when we use this to sign transactions so that other people can go send them, and so that kind of we all as a community, know what data is popping up when we see kind of these random bytes and bits and all this nonsense stuff. If you want to see kind of more notes on this, I've got a shit ton of notes here. I'll probably have an article on this at some point. But with this in mind, our get signer becomes a little bit more verbose, right? So without any structured signers, we just have this stuff up here. We go, hey, so, let's get the hash of a message, ECR recover, boom, you get the signer, no problem. Now it gets a little bit more advanced here. So if somebody has a message, or it's gonna be a number, for us to get the signer, we actually have to know all this stuff, right? So first we get the prefix, but this is actually why I wanted to make this demo, because I'm trying to like make it minimalist and easy to comprehend here, right? So this signature has 4 parts, right? The prefix, the version, version specific data, and then application specific data. So for this example, get signer 191, you need to start our hashed signature with OX19. Our version is going to be 0. So this 0 version is defines like data with intended validator. Don't worry about that right now. So that's going to be bytes 1 of 0, and then some intended validator address. For our example here, we just said address this, and then our application specific data. This is like our message. I just used a uint256, which I hashed by using byte 32. This could be a string. This could be like whatever you want. And it's the combination of these 4 things that gives us our hashed message. So now you see in here, we do ABI.encode packed. That basically just like concats, smashes these all together. And then we cacac 256 it. So we hash it. Boom. Now we have this hash message. Now that we have the hash message, we do exactly what we did above. We pop that sucker into ERC recover with the VRNS of the signature. Boom, we get the signer. Now it's super easy for us to verify the signers because we just get the actual signer, and then we check to see the actual signer is who we expect it to be, and boom. So in order to understand, and this is all just to understand signature replays, right? Like a lot of people think they understand signature replays, but I've seen it, and most people actually do not understand signature replays because they don't understand this stuff. And this is the prerequisites to be able to protect other protocols. I needed this like 2 months ago. Oh wait, I'm going to turn my be focused on. Can you all see it? Can you all see my be focused? Why can't you see my be focused? Oh, what the heck? Well, give me 1 second here. Let me fix this. There we go. Okay, cool. Are you all with me so far? I spent a week trying to learn EIP-712, and I don't think once I saw EIP-191 mentioned. Oh, okay, perfect. So then I'm doing this at the exact right time for you. All right, cool. How does this relate to EIP-712? You will see. Great question, my friend. You will see. Okay. Cool. Okay. So the reason you need to know this is because this is the heart of the cards. This is what we need. We have prefix, version specific data to sign. Great. Now, we said, hey, cool. Now we have this kind of format that we're all going to follow for signed data. Huzzah, hooray. But there's still an issue. Okay, well, what if the data that we use is like super complicated, right? You know, for example, in our README, I have this like picture here. Our MetaMask is actually popping up with kind of this mail from person named Alice, blah, 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 2%, blah, blah, blah. How is it able to format that? So this is like the data that was signed. How did the MetaMask pop-up know that was the data? Well, that leads to the next bit. You need to, and we need to have a format to say, hey, when it comes to data, we're all going to use the exact same data format so that all of our wallets and all of our signature verifiers can all follow the same format, so that when our MetaMask pops up, we can all populate it the same way. And that will relate to signature replays in just a second. So, cool. Thanks so much, OpenSense, for popping by. Yeah, it's going to be kept here afterwards. Yeah, so if you can always replay this, I'll probably make some more content on this as well. And a lot of the times, sometimes when I make content, I like make it for myself too. So a big part of this too is just that I could have like it like written down in place so that like I'm like, okay, like I know where to go back to like make sure I know what the hell I'm talking about. Cool, but we have, so verify, sign on 191, yeah, super simple. And then I have some tests as well, which test all this actually works. So we can run through the tests too. And then there's just one more that I have to build. So some of you will just be building with me and follow along with me building. Okay, so finally, EIP-712 signatures. Anyways, we said, hey, cool, you know, great. We have a way we're all gonna sign stuff, but we said, hey, it's not enough detail. The 4 through 6 application-specific data, can I toggle word wrap? Thank you. Wasn't specific enough, right? So this data to sign bit, we said, hey, this is cool, but like, it's for like super complex data, we need to be able to like tell the user what the hell they're even signing, right? This was cool, but it's not specific enough. We need to format the data to sign as well. This will help, like I said, for wallets, but it will also help for, what did I just say? Signature replay. So now, instead of just having this as our kind of our format for signing stuff, we now have it as this. The prefix, the version, this thing called domain separator, which is associated now with 0x01. This 0x01 stands for this like structured, what is it called? I don't know. Oh. Yeah, this type structured data. 0x1 is the type structured data. And now we're going to need this domain separator and then a hash struct of the message. So this is what all of your hashed, this is what all your signed, this is what all your signed data is going to look like. Oh, what up, Anna? So the domain separator is basically some combination of these verifying bits of information, name, version, shandy, verifying contract, etc. So that's your signature can be unique to this chain, the contract, blah, blah, and you'll add more unique stuff in the hash. But yeah, all this combination of stuff is known as the EIP-712 domain. And this is really good because there can only be one contract who verifies it. It's good for a whole bunch of other reasons. I have a whole bunch of other notes in here where we kind of go super mathy into like, oh, okay, well, due to this definition, here's what it expands to. Due to this definition, here's what it expands to. This is kind of like the final, like what it looks like. But my summary bit is basically here. So now our signatures with this kind of new hash structure format, they're going to start with the prefix, same exact thing. They're going to have the version, same exact thing. They're going to be the version specific data, same exact thing, except for this, in this version, we're going to have the hash of who verifies the signature and what the verifier looks like. And then for the data, the message we want to sign, we have a hash of signed structured message and what the signature looks like. So we're kind of just packing a ton, way more data into this. And if you're not super following along, that's okay. Because I'm going to make more content around this, and you should definitely read all of my notes in here. Because yes, if you don't understand EIP-191 and EIP-712, you actually don't understand signature replays. So now you know. But okay, so what we have to do for this is we have to do a whole bunch of wacko weird shit that was super frustrating for me the first time that I did this, because I was like, can you just verify my freaking signature? And I like didn't understand why it wouldn't just verify my signature, but now I get it. So the first thing we have to do is we have to make this EIP-712 domain struct, and we have to make a type hash. So basically we need to have this type hash, which tells the users who are using the signature, hey, this is what the struct of the domain looks like. This is who's verifying this, blah, blah. And this has to be, and for us, what it should be created right in the constructor, right? Because you want the verifying contract to be, address this most of the time. There are going to be some scenarios where you do it other places. You're going to have a very specific chain ID. This is actually really important for cross-chain signature replay prevention. But yeah, you add this shit in the constructor, and then you set up the actual domain separator right here. Again, if I'm like not making any sense, don't worry too much about it. This is just basically kind of important stuff to say, hey, who is going to be verifying this signature, and what format do they look like? Boom, domain signature, cool. Domain separator, got it. Then we actually have to put our data into a hash struct. So again, this EIP is for structured data, which is important for signature replay. So we have to put our data. So we're going to practice putting our data into a struct. This struct is obviously super minimalist. It's just this thing right here. But this is what we're actually going to be signing, right? Well, actually, we're going to be signing this too, but I'm ranting a little bit. So we're going to, this is the data we're going to be signing. We need to tell the user what the data that we're going to be signing, the struct of what it looks like. We use that with this type hash thing here. And now, remember, all the way back up here, in order to get a signer the simple way, we just said, okay, let's hash our message and then recover. Now we're going to do a whole lot more shit. But the cool thing is, it's still just these 4 steps, right? It's going to be the initial prefix, the version, version-specific data, and then the data to sign, right? So this is why for EIP-721, it's important to understand EIP-191, because EIP-721 is the exact same, still follows EIP-191. It just says, hey, the way that we're going to do this version-specific data, number 3 and 4, are going to be different, right? If we scroll back up to 191, we said prefix, version data, data to sign. So for EIP-712, version-specific data is our domain separator, and data to sign is going to be our signed hash structs. So all 712 does is tell us, hey, we're going to format these last ones of 191. So this is where people who are like, hey, I've never heard of 191. Well, then to me, I'm like, well, then, hey, you don't really understand signature replay attacks, do you? Just these 2. That's all 712 does. Cool. All right. Yes, this will be uploaded later. Does the 712 specifically address domain-related aspects in Ethereum, while EIP-191 provides a more generalized framework for signing data? I would say that's almost a good way to think about it. I mean, so like maybe the easier way to think of it is like, yeah, EIP-191 is like sign data like this. And then EIP-72 or 712 is like follow 191 and then structure your signed data like this, if that makes sense. So yeah, EIP-712 just follows 191. But anyways, so we're going to do the same thing. It's just going to be these 4 bits of 191 with, the third and fourth following 712. So in here, we're going to have our prefix, same as before. Our version is now going to be 0x01 because we're saying we're going to follow this 712 version. We're going to do our domain separator, which we've already defined above. And then we're going to hash our message struct by hash our message struct and our message type hash. So this is actually why 712 is so cool, because we hash the actual message, and then we also hash this type hash, which tells the decoders the format of our structs. A lot to think about here, but I promise it's cool when you play with it. Finally, we combine them all. Traditionally, when you like hash all this stuff together, you call it the digest. Yeah. And then boom, then you just do the same thing. ECR recover, and then you can verify the same way. Milady. What up, ancient Roman Doge? So that's where we are so far. And I have forge test. Oh crap, I don't think I finished my test. Oh yeah, one's busted. Well, other than this one, oop. Other than that one, all my tests are passing. Huzzah. The tests are also pretty cool because you can actually see how you can like sign stuff in here. So like sign stuff in Foundry. So verify signature simple. I have this kind of sign message helper function down here. Foundry has this vm.sign thing that we can use to sign a message. In most of the time, like signing a message isn't something that happens on chain, which is like kind of bizarre for Solidity developers. Usually when you interact with like a website, they're using like ethers.js. There's like some sign library. I forget what it's actually called, but yeah, this basically replicates doing that. And it also shows you how to build these signatures right in Foundry. So if you want to play with this to like learn how to build with signatures, feel free. Play around with it. Try to actually, maybe build a signature that doesn't work, or try to, figure out how to verify and create signed data. Play with signatures. Get good at signatures. It's good for your health. And then finally, so now I'm working on this sign message replay resistant. And this is kind of the one that I'm working on right now, and the one that I will be continuing to work on for the duration of this stream. And basically, we're taking all of the things that I just went over, and we're just adding replay. We're just making it replay resistant. And the reason we need to know all of this other stuff that I just talked about is because we want to encode, we want to sign replay resistant data right into our signature so that it can't be replayed. So some of the things we want to think about when we're signing data that is replay resistant is going to be using a nonce in the data, an expiration date, restricting the S value. I'll talk about that a little bit, using a chain ID, and then any other unique identifiers. And oh, sorry, 1 second. Our lady's going out. She looks dope. All right. See ya. I lost my train of thought there. Anyways, yeah, so these are the things that we actually want to sign. And guess what? We're going to sign it in the format of EIP-712. Oh my goodness. So we're going to structure all of this data into EIP-712, sign it so that our signatures are replay resistant. So that's what I'm working on here. I'm going to be basing my, minimize examples based off of Uniswap's permit 2. Yeah, Uniswap's permit 2 code is some good code. And they do signatures, and if you're unfamiliar with Uniswap's permit 2, definitely recommend looking into it. It's good stuff. So I'm trying to basically like make a minimized version of kind of what they did. So any questions before I go back to coding? Thank you, Ancient Roman Doge. The main thing I would think a way to validate who it was signed for when it comes 712, because the sign hash contains detail. The main thing I would think a way to validate who was signed for when it comes to, could you rephrase the question? I'm not sure I'm totally following. When are you going to learn Move? To be honest, Max, it's low on my priority list. Yes, expiration is good. Not necessarily all the clients using it might validate it or have a logic to validate expiry. Well, they should. They should. If they don't, then it's not a very good protocol, then is it? Quarkosaurus, a bit of a random question, but I'm glad I caught you live. How do you think blockchain/DeFi is going to shape the economy of the future? I think we're all sick of this inflation. I think everything finance will be on chain at some point. And I'm very excited for that day. I'm very excited for the day people's 401ks are Aave. That's going to be sick. Cool. But anyways, all right, I am coding now. All right, and here's where we are so far. Test. This is my signature replay resistant test here, and it breaks. Because it doesn't even compile, which makes sense. I forgot where I was last night. So I've added the message, deadline, and the nonce. Or I think I was going to start. Oh, that's what I was doing. I was starting from the test. So this is the permit 2 test permit. They had a nonce. Forget where they get permit transfer signature. So this is the signature that they use, and it's going to look real similar to like what we're doing. This is just going to be my message, which I already have defined. 26. That's my message. Default. I think this is just like, yeah, nonce to deadline. I've added a nonce to the deadline. Then they actually, okay, this actually does the signature here. I do the same thing, domain separator. Yeah, I do the same thing. Prefix version. I get an unused nonce a little bit differently than they do it, but then I sign, then I hash it with the type hash, with the message, which uses the actual message, deadline, and a nonce. And then I sign it down here. Okay, it looks good. And they just do transfer details, which is fine because they don't need to actually sign that. And then they do permit transfer from. They do it with this one. It's this. This is what I was playing with. Sign. The sign looks good. I think my sign is good here. I get the VRS. Having an issue with message. So this should be the hash. Yeah. So I need the replay resistant message. Replay resistant messenger. What is it? Number deadline nonce. Number message deadline is gonna be block.timestamp plus the deadline extension. I would just do the same as this, I think. Hashed message struct. Oh, I'm violating dry a little bit here, I think. Did I do this before too? No. What up? What's poppin'? Nonce. Yes, sir. Now you know how to say it. $30 years old? Hell yeah, I'm 30 years old. You're not too old at all. I know a lot of coders who started at like 35. You got plenty of time. Why am I blanking? Sign message. Because, oh, okay, that's why. Test replay resistant. Because this needs to be, I should send the hash. That's why, okay. So instead of this, I should send the hash message struct. Actually, I'm just going to make a helper function called, yeah, get hashed, get replay resistant hashed message struct. That's what I'm going to do. I think this is right, actually. And then in here, we'll just do this. Boom, much better. Okay, much better. Now we can go back. Message. And I don't have to do this anymore. I'm still violating dry a little bit, but I can say at least hashed message struct equals like this. And that should work. And then I have assert equal verified once, true. If I try to verify it again, it should revert. I should, oh, but I didn't finish this. Okay, well, let's test it. Hashed, oh, Lamau. Still mess something up? That's... Ooh. Needs an unused nuts. I gotta do that here still, and I think that's fine. I made a final year product and one for... Oh, hell yeah! Oh, that's what's up. Mr. Dead started at 40. Oh, that's what's up. Oh, I did it like that. I should just get the message struct. Let's do it like this. Get replay resistant message struct. Returns. Signature. Blah, blah. And then instead of hashing it, coding it and hashing it, we'll just do like this. Replay resistant. So that says now. Is that right? Replay resistant. Message struct. And then I'll say bytes 32. Like this. Yes. I think that's right. And then I gotta fix up here. We're gonna do... I guess that's kind of redundant. Right. Hash message struct. Message signer. Yes. Makes sense. Hash message struct. So this is going to be... Make sure verified at this. This is going to be message struct, not the hash. Message struct. Good. 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 And this should not be view because this... Good. Okay. Now this should fail because I didn't finish the verifier function, but it should all be set up. Okay, it did revert. I don't know why it reverts. Verify sender. Custom error. Expect revert. Why did it revert? Should use custom errors, but I'm not. Whoops. Need unique nonce. Need unique nonce. Good. Because using the same. Oh, good. Okay, cool. Oh, that's really good. Nice. So that's what we want. But why did this actually incorrectly verified this first one? Because I have returned true at the bottom. So that means I need another test here. Function test. Incorrect. Are not verified. Let's do the same thing here. Sign as a replay message. Make it wrong. V equals V plus 1. If V is equal to uint 8.max, V equals V minus 1. Max uint. Oh, type uint 8.max. Good. Okay. Those are not verified. Make it wrong. Blah, blah, blah. So this should now fail. Verify the manager. Blah, blah. I don't even need to prank anybody. False. There we go. VM.expect revert. And then it's going to fail because it's not going to revert. It's going to say it passed. Okay, good. We're cooking. All right. What'd I miss? GM. Mapping revoked signatures. Hey, Patrick, since the V parameter of the signature already includes the chain ID for its calculation, isn't it a bit redundant to also add the chain ID to the domain separate? The V parameter of the signature already includes the chain ID for its calculation. EIP-191. Good question. Simple replay attack protection. Our boy Buterin. So this is actually where this gets confusing. I think, and I'd have to double check on this. I think this is for, yeah, that's where it gets confusing. I think this is for signing a transaction, like all of its data, versus signing like a function. I'm hoping that I'm hoping that actually made any sense. I don't think it did. So, yes, but no. Yeah, that wasn't helpful at all. How do I check my, oh, this is how I do it. Yeah, I think this is for signing transactions, which is confusing because it's like, dude, what are you talking about? You're signing a transaction. But so like the stuff we're doing here is like signing data where a function will actually check it. So this here, yes, but no. Yeah, it's for like an RLP encoded transaction. So like so this is like a transaction like you send to like an ETH node, and this is like all the data. This that we're looking at in here is like a signed transaction within that transaction. Oh God, I might have made it harder for you. I'm so sorry. So good idea, but I don't think this applies here. I think. I could be wrong, but I'm pretty sure it doesn't apply here. Great question. What if there's a method writing the contract could be used to revoke signatures once used? Signature function revoke signature. You could probably do something like this. Yeah, you could probably do something like this. You have to add the chain to the domain separator because ERC same works across all chains. Yeah, yep. It prevents replay across contracts and chains. Nonce prevents replay within the same contract. Yeah. Thanks, Tox. What if the nonce was never used in the parallel chain? I should be able to use it. I think that maybe deciding factor got to be format EIP-712 plus chain ID. I think you have to use the chain ID. Nonce is not useful in multi-chain. Yeah, I think that you have to use the chain ID. I might not be following this. What's going on here? Yes, but no. Yeah, okay, cool. It sounds like I might have explained it well enough. Hopefully I did, but I might not have. But anyways, okay, cool. So now we have a failing test. Now we can actually finish doing this. Exciting. All right, verify signer replay resistance. So we're just going to copy the format we did for verify signer. Oh, wait, what? Oh, no, this is where we're going to copy permit 2. Yes. And then we're going to do this signature malleability stuff at some point. Okay, permit transfer from, okay, verify. And this is where they do a whole bunch of like extra shit that I'm not going to do. I'm not going to do that. There's like a bunch of EIPs where like the signature length can be like different, or like you have to do something different for contracts and all this shit. And I'm just not going to do that. I'm going to say, hey, there's some other stuff you can do. Use Open Zeppelin when you want all that stuff. Verify an upper bit mask. So this is signer. Did I do that already? So I have get signer replay resistant. I'm not doing the signature malleability protection yet, but I will, I promise. So I think we just then do, we check ERC. Oh, we don't check ERC recover. Oh, wow, that's kind of bad. Oh no, it's fine because, okay, yeah. Address actual signer equals get replay resistance. Message deadline nonce VRS. Yeah, okay, cool. Actual signer. Require signer equals actual signer. Okay, cool. Restrict S values to a single half. Shit, I didn't do that yet. Require do I not have the number deadline nonce? Is this about cross-chain calls? Yeah, we're adding cross-chain signature replay resistance as well. Where do I check the chain ID though? Because we have it in our domain separator. Get signer replay resistance. So that should be fine. Do I need to check it? We have it in our separator, so it should be okay. I think, right? I might have to test this later. Do I need to use the permit too? They don't do anything with chain ID, right? Because their domain separator has the chain ID already, right? Domain separator. Domain separator. Permit to dot domain. Okay, cache chain ID. Right, so theirs has the chain ID. They never check the chain ID anywhere, do they? It's just they wouldn't have been able to sign it if they didn't have the chain ID, right? Testament separator after fork. They don't actually have a test here to test. Because it shouldn't matter. Test domain separator. Because you can't sign it unless you have Right. No, this makes sense. So I shouldn't have to check it. Build domain separator, build domain separator. Yeah, I don't think I should have to check it. So this should be fine. So I just think I need to do the signature malleability thing, and then we're good. Require signer equals actual signer. Because now if I run my test, it actually will pass. Or it should pass. Actually, let's make sure this passes first, and then we'll try the signature malleability thing. Oh, fuck yeah. All right, we did it, team. Cool. So this should be, let me actually commit this. Oh, ew, what the hell? Update for, I think this works now. Cool. Cool. So now we just have to do this. Signature malleability stuff. And just when I sign, Chad, love using git command line, no UI. You know, some people have told me that it's actually Chad to use the UI. But I don't know. I think I'm decent enough at Git. I don't need the UI. Controversial. Yeah, Equius. Git has there's a GitHub UI. I don't use it that often myself. And by that often I mean I never use it. But yeah, some people have told me it's way better and I should use it. Your library generates malleable signatures such as S values in the upper range. Calculate a new S value with this. So I think I just slap this on here, right? Flip V from 27 to 28 or vice versa. I think I just have to do this. If S is in the upper range, just be like, that's no good. Scientific S, upper range. I think we can, so I think we just do revert add S. How do they test this? Try recover. It's all hard hat, right? Utils. What is it in cryptography? do I just? Cryptography, ECDSA. Okay. ECDSA.test.js. Try recover. Do they have no test for try recover? What the? Did they not test try recover? Am I like, am I dumb? Try recover. Invalid signature S. I mean, they should have a test with this, right? Details. Maybe it's in signature check. Oh, down here. Verts with high S. Oh, maybe their mocks recover is just try recover or something. No, because this is a different error though. ECDSA. There's a test for S in the higher order. Is it sanity test? Or is it in here? Hey, Prometheus, get some sleep, my friend. Signature checker? No. Yeah, in the ECDSA file. Tills. In this one? Valid. I mean, these are the only... Invalid signature length. Oh, whoops. No, try recover. I need this. Invalid signature S. I don't think they have a test case for this. They have ECDSA invalid signature S. Maybe there's some weird... Ugh, I hate GitHub search. Ugh. I'm not going on break yet. I need to figure this out. Yeah, the higher S test. Where? Higher S. Or this one? The highest signature? I mean, this is the one that I'm looking at, right? This is a different custom error. Yeah, it's a different custom error. Row error. What the? I hate it when people do this. I get it. I understand why they do it. I just don't like it. Invalid signature. Error. Optionally reverse with the corresponding custom error according to the error argument. Throw error. Oh, okay. So they are. Okay. So these are the same thing. Got it. Okay. So they just have like, they just have a straight up custom message and high S signature that they tested. Okay. I'm not gonna do that. Yeah, I think cool, makes sense. So, okay, well, I think this is good then. I think this is actually replay resistant now then. We have a nonce, we have a deadline. I just would need to check. We make the nonce true, so I shouldn't be able to use it again. Latest nonce. I guess some jerk could do like a crazy weird nonce and put it out of order, but it shouldn't matter. So this should prevent signature malleability. And then and then this is good. Am I missing anything here? I think this is good. Cool. Let me just double check. Does permit 2 do anything else that I need? We have a nonce. Yeah, actually they do all this other crap. We could do this. I'm not gonna do this. What up, Lucian? Indeed. Live and not dead. I'm not gonna do this. Signature.length equals 65. I probably should. What happens if I think I have like optional, but ideal. Check the signature length to look for yep. Claim it is correct. Contract compatibility. Yep. Makes sense. What else do they do? Sure. And then they do this crap. So if they have code, claimed signer is valid signature. So this is like if somebody else is the claim signer. So I guess we would say, okay, so mine is, this isn't like, this is still replay resistant, but it's just not like, doesn't have all the bells and whistles. So I would just say, like a note here. This doesn't have all the bells and whistles like contract resistance or like contract claimants, signature length, etc. Sometimes I feel that solidity is short. Am I correct? What do you mean by short? All right, cool. I am very happy with this. Nice. Okay. Cool. So now I'm probably going to go on break, and I'm going to move over to doing some stuff with Certora, because that sounds fun. So I think a lot of y'all came over from Twitter. Is me saying I'm live on Twitter like something I should do, or do you guys like hate that? Do you guys feel like baited that I baited you into coming over to YouTube? Ugh. Yeah, let me know. Let me know in the chat here if you guys hated that or if it was fine. I might end the YouTube live stream or the Twitch live. I don't know. Yeah, you on Twitter, same thing. Like, let me know if you feel like baited or if you feel like doing the Twitter live to point over to YouTube was cool. We want to get baited. I got a YouTube notification. Okay, cool. Cool. I joined like 2 minutes ago, but IMO, I like it. It's good. Did you join from Twitter or did you join like straight up from YouTube? Was slacking on YouTube randomly came across this video, so I'm sort of slacking YouTube news feed. Oh, so most of you didn't even come from Twitter. Most of you straight up came from YouTube. Yeah, from Twitter. Okay, so some of you came from Twitter. All right, well, if you feel baited, let me know. I'm gonna, yeah, I'm just gonna leave it up actually. YouTube. Okay, dope. All right, cool. All right, I'm gonna take 10 minutes. I'll be right back. Yeah, then we're gonna switch over to doing some Certora stuff. So see you in 10. right, we're back. Oh. Over my sign. Cipher, hell yeah. Okay. Let's do this. All right, we're switching gears. Doing some Certora. So, Lucian, yeah, we got one coming hella soon, actually. All right, so we're moving on. As many of you know, I'm working on part 2 of the security course. And I was mid-filming, and then I went, shit, I want to add, like, a ton of stuff. So I'm working with Certora a lot here. And Certora is a form of verification tool. You'll have to, for those of you who don't have context there, form of verification is basically a way to mathematically prove your code base does a certain thing. So, yeah, and I've already done, up to this point in the course, I've already done a whole bunch of like teaching how it works, how to use it, blah, blah. But I want to add I want to basically show some more stuff on how it actually works. So how to use it to do really cool stuff. And these are some of the features it has that I want to add into the course. And I didn't think it made sense to add these into the course where I like introduce form verification. I want to keep that one kind of minimal so that it's easier to comprehend. I guess this is a little bit of, reveal behind the curtain on like how I kind of think about course creation. You don't want to give people too, much to chew at once. You want to kind of piecemeal them, because our brains suck at just like, here's one big problem, now go off. It's much better like, okay, here's a win, here's a win, here's a win. So introduce form verification kind of easily. And now that people know about it, know how it works, now I'm going to dump on them kind of a much harder project. So this is kind of a last minute introduction. I want to make this real quick where I just have, a code base that's hard, not because like hard for the sake of hard is kind of dumb, but hard for the sake of teaching like these newer concepts is what I'm going for here. So I want to add all these different features that Certora can do. And I'm trying to think of a good example to showcase them. And I think I might do like the horse store stuff from a recent first flight. I think that actually might be really good for this. So for recent first flight, I made kind of this horse store NFT, which doesn't really do too much, but like it's in Huff. And it had a whole bunch of bugs. It's in appeals right now. And this might be good to do all this stuff. So I'm going to be like, if you can't follow along with me, sorry, I don't know what to tell you. But hopefully this does something good. Codehawks 1 million USD contest when? Good shout. Good shout. Maybe we got to get Viper on. Do something with Viper there. Cool. All right. Well, anyways. So here's what I want to do. I want to add all these in here. I think I want to add all these in here. Whoops. Ghosts. Would I need ghosts for testing this? I guess I wouldn't need it, but I could. I think I do ghosts with this. Hooks, I could definitely do hooks with this. Parametric rules. I don't know if I could do parametric rules. Define methods. Parametric rule example. What is a parametric rule again? I don't know if I missed variables or something. Undefined method variables are sometimes called parametric rules. So I would need some type of unknown, basically. Or store might not actually work. Actually, I might have to make a new demo. Unless I did like abs. Feed the horse gas to keep it happy. You gosh darn right. I might have to do a different one. Well, what is this? The term get customer is get customer a methods specs banks. So what is? But get customer is defined. What the? Get customer a.id. Get customer a.id. So what is? It returns a customer. Oh, so this is a struct. Oh, that actually might work really well. Bank account record. Bank account record. But it does exist. Kind of a shitty example, huh? Get customer a.id is not supported yet. F.contract. Method F. E args. Call data args. So this is saying what? Integrity of customer key rule. Call data args. So for customer C is get customer A. C is A or it's 0. Fine. And do any function is parametric just because it has this in here? Why is this parametric? It is an error to call the same method variable on 2 different contracts. Why? Is this an older version? This must be an older version of Certora. Wonder if it says the version in here. Info. Doesn't say the version in here, huh? Probably should. Conf specs. Global. Yeah, I don't think it says the I don't think it says the concurrent viewers. Well, I don't know what I'm saying. I don't think it says the version. Yeah, so this is probably the old version. Got it. Okay, that's fine. So I just get to come up with my own parametric rules. It's kind of fun. Multiple dispatcher and summaries, Lupiter sanity prover arcs. I already did that. I think I already did sanity too. Is Certora free? It's a freemium. So you get a bunch of runs for free, and then if you start to use it too much, they start charging. Basically just like a cloud form of verification tool. I guess I could probably just do this with like a minimal. I probably don't even need to do, you know what? This is going to be ghost hooks, multi-contract dispatches. That's probably going to be the hardest bit, right? Let's just like look. Okay, what do I need to do for that? Dispatcher summary. I might make just a slightly different version of CVL by example. When signing a message, we also say RSV. R and S are part of the ECDSA standard, but V is specific to Ethereum. Can we always use 27 or 28? And what other data can this be used for? Love your stuff. Much appreciated here. I forget. I think you can. I think it depends. I think it depends. I think it's. I'd have to double check, to be honest. I don't remember off the top of my head. I think it's like you should use 27 or 28, and like some libraries use like 0 or 1 or something. I would have to double check. Yeah, good question though. All right, so I want something with multiple contracts. Maybe have a DeFi E. Declaring ghost variables. I mean, ghost variables are no problem. I could do like the stablecoin bit, but I feel like that's so over the top. What do I want to do? You know what? I might just. Because the other thing I could do is I could just make like a super basic smart contract and then just do like over the top form of verification on it. They can pay stable coins to buy hay for the horses. That actually sounds awful to code in Huff. I mean, anything is awful to code in Huff. I'll have to code in Huff live once. Like watching me code Huff just like kind of sucks because I'm just like, what's on the stack now? What's on the stack now? Now what's on the stack? I feel like the math heavy stuff is just it's so good though. Like that's like the purposeful form of verification. I almost feel like it's, you know what? No, I'm gonna do. No, we are gonna do this. No, we are gonna do this. We're gonna do the horse store in Huff, and we're gonna formally verify the shit out of it. That's what we're gonna do. I'm gonna call this Super Horse. Super horse store. And we're just going to formally verify. That looks good. I wonder if something like visual binary analysis could be used on Solidity bytecode. That would be pretty sick. Christina, I would like to see that. Super horse store. Super horse store now found in iSuperHorseStore.sol. Well then, what is this? Okay, I changed something, I guess. All right, we're not going to write any tests. We're just going to formally verify this. Bitch. All right, well, let's do it. I think Certora NFT example. I think Certora has some NFT examples I can borrow from as well. Certora. I remember this. ERC20. Ghosts and hooks. I thought they had a... Maybe they don't. All right, well... Look at this on the side. Okay, well, in our Certora folder here, I want a couple of stuff. We want a comp file, our folder conf. We want a harness folder if we need one. Spec, oops. A spec folder. All right, cool. So let's do a sanity spec. So we'll do super horse store dot spec. Let's do paste this. This is going to be src super horse store. Do I have to put a... I'm going to do this in Math Masters. Certora. Oh, because it wasn't in Huff. It was in Solidity. Oh, so we do have to do a harness. Okay, so I need to make a harness. Super horse store huff harness.sol. This is going to be 0.8.20 contract super horse store harness huff import super. We're going to need huff deployer. We're going to need super horse store. Or actually, super horse store from there. SRC / right here. Is Foundry Huff. Foundry Huff is in here. Oh, Forge build. Certora. Harness. Super horse stuff harness to sol. Forge. I think it's not building because out. There we go. So I want to see super horse store harness. Yeah, okay, so it's not building it, right? Because it's not in SRC, obviously. That's kind of annoying. So I would have to put the harness for this actually in SRC. Or I could put it in test, I guess. Wait, but it compiles test, so why isn't it compiling Certora? Hey, thanks, Drennan. Love you too, my friend. Build. I doesn't know what directory. Contracts. The contract source directory. But also, oh, okay. Here we go. Test and script are aliases for t.sol and s.sol. I won my first award last week, $150. Let's go! What contest was that? Yo, that's what's up. Huge congrats, my friend. Still not. How do I get it to compile this? Oh, I can do it like that. Model checker. The contracts path. the model checker. I don't want to put in harness. We're going to call this Certora harness. Better. Okay, good. Missing implementation. Okay, good. Okay. Nice. Program horse store location. It's located at Super Horse Store. Right, Super Horse Store to Huff. Okay, good. Instructor. Oops. Okay, and then we're gonna do my Super Horse Store, public Super Horse Store. We're gonna say Super Horse Store equals. I'm gonna cheat a little bit. Like this. Super Horse Store. NFT name, NFT symbol. Marked as abstract because why is it abstract? Because I need to do this as well. What? Revolution protocol. Huge congrats. Nice work. That's what's up. Super Horse Store harness huff. Why is it mad at me here? I'm being super stupid. That's why. This should be, I'm deploying a contract in it. This should be the contract itself. That's why, because I'm being a total idiot. Actually, no, I don't know how to do huff in Certora. So I think I would need, I would need to get the huff as the solidity. I have no freaking clue how to do that. What up, Jax Coder? Well, okay, I'm going to do something that I don't think Certora was meant to do. Let's see if there's a way I can do this. I guess I could make this contract just a straight proxy for this, right? I can make this. Yeah, actually, that's shit. That's how I'm going to do it, actually. So we're not going to do this. We're not going to do this. We're going to explain what we're doing, and we're going to try this, and we're going to see this works. Title. Author. What was it? Equius Lover? Or Equestrian. Sorry, Equius. Not Equius Lover. Equestrian Lover 420. At dev. This is going to be a proxy contract for our Huff contract. Why? Because we need to let our Certora know what's up. IDK if this will work. Nah, we're going to leave that out. Cool. We're going to do something brand new with Certora. Let's see if this makes any sense. All right, Superhorse Store. Oh, I do need to import this. Oh, wait, can I do this? Can I just say is Superhorse Store? And then for all the functions, I would just be like, is there a way that I can just say, hey, I mean, I know how I can just be like, hey, you know, do everything over to this contract. But can I keep the interface like that? I don't think so. I think that's gonna mess up Certora. Ugh. Okay. All right, what is it? Simple proxy contract. Solidity. I do these again. Proxy delegate. No. This one's probably good, but I think I did it in Foundry full course. See what our boy Programmer Smart did. They did minimal proxy. They did the assembly. What did I do? So proxies, proxy contracts. Yes. What did I do? Was what I did good? Sublesson, small proxy.sol. I used Open Zeppelin's proxy. Which is basically just, okay, I'm going to do the same thing. Yes, we're going to do this. Ew, I didn't use a named import. Y'all didn't call me out for that. Disgusting. Disgusting. Can't believe nobody called me out for that. Okay. It doesn't come with a receive. Proxy, fallback, fallback, fallback. No receive, huh? Can I build a backend on chain without using Solidity? Can you build a backend on chain without using Solidity? You absolutely can. You can use Huff. You can use a Viper. I wouldn't use Huff though. I would use Viper. Hey, Drennan, keep it up. Just getting started here. Horse language. Spot on, my friend. Okay. We're gonna add this. Yeah, I'm getting there. Okay, we're gonna receive table virtual fallback. Wait, why do I even need that again? I forget. Actually, you know what? Receive. If they send money, we're just gonna revert. We'll do a little custom error here. Don't send money. convert. Good. Make sure we mark as abstract. Why? What am I missing from proxy? Internal virtual. Oh. Internal view virtual. Internal virtual. Internal implementation. Overridden. Okay, that's what I need to do. What are I doing here? Oh, implementation. Lamau right here. Set. Oh, I have a set implementation. We're not going to do that though. Implementation. Implementation select. So right in our constructor, we're going to do this. Yeah, we're going to do this. Oh, did I already screw this up? I already screwed this up because this has storage. Ugh. I would need to make this upgradable, and I don't want to freaking do that. Hey, thanks, C. Much obliged. Can you teach us to code tokens on Solana? It's on my to-do list. Please, you have any plans to teach on L2 development? Here's the beauty, my friend. Everything that I'm teaching you works on L2s. So I'm already doing that, my friend. I got you. Got you. I already effed this up, which is fine. Which obviously doesn't make sense with a proxy. However, for our Certora stuff, we are not going to be checking this storage stuff. Fine. Was the session already planned or just a night surprise? Well, so you know, obviously I work a lot. And I was like, hey, you know, I might as well just stream myself working, and then if people want to ask questions while I'm working, you know, great. Hey, Brian, appreciate you for being on the stream. And then, like, you know, I guess the other thing is it like lets you guys see like behind the scenes, like how we come up with courses, and you know, even my process of learning, because I'm not like a, you know, you'll see as I'm doing a lot of this stuff, like I'm often learning as I'm doing, like, you know, how do you work this much? I mean, all day. I really only started at like 3. You know, I wouldn't say that's all day. I like went to the gym and got my fitness on first. So this is like kind of shitty, but I think it'll be fine for what we need to do. So we just need to do set the implementation here like this. Only local available access to oh, duh. Okay. Cool. See, I already fucked up because I have. Oh no, these are public constants. So that's fine. This is a constant. Do I have any actual storage variables here? See, this is why I do like the s underscore. So I have an actual storage variable here. So this doesn't make sense. I need to take this out. Restore location. Fine. Okay, those are good. Okay. How come you can only build blockchain backend on Solidity Viper if Ethereum is written in Geth and Rust? Do I always have to use EVM? So Ethereum is EVM. If you want to use a different blockchain that's not EVM, yeah, actually Equius even said it here. If you want to use a different blockchain, you would use a different blockchain. Yeah, I see the EVM like an old 8-bit computer with all the problems associated trade-off between memory usage and CPU cycles. All right, we're gonna see if this works. I feel like this is gonna be so janky. I don't know if this is gonna work. Where is it in test? Or let's do forge build. It's so janky. Super horse store huff harness. Okay. Okay, let's do a sanity check. So let's do, say, methods, function, is happy horse. I should probably actually fix this so that it's good. I'm not gonna do that. What the heck did I do wrong? Oh, it was the view. Oh, okay. Got it. I use Command K a lot, but I also just like type clear a lot. I used to use Command K more, and then so the Command K key. So ready, watch this. All right, so if I'm on README and I do Command K, it actually like gets confused. So I just like am in the habit of doing clear. Oh, I also have an alias called C that does the same thing. And I just still type clear, just like bad muscle memory. Let's just do like rule. Yes, we'll say rule is happy horse defaults to true. This is such a stupid rule. It's a unminted horse should not be happy. Let's do that. Is happy horse with a 256 horse ID. Now what are you mad about? No, you're fine. So what do I want to do to unminted horse should not be happy? So first, I want to say is happy horse. Bull. What did they do here? So I would say bull is happy equals. Why is it mad? If do I have a total horses? I do. Innumerable total supply. Horse ID is greater than then assert. Oh wait, no, I want this to revert. Is happy horse at with revert. Okay, here we go. If horse ID is greater than function total supply external returns. This is greater than total supply. Assert last reverted equals true. Is this right? I think this is wrong. I think that's wrong. I think we don't want conditionals. I think we don't want conditionals, yeah. Oh no, here's what we do. If, oh yeah, here's what we do. Okay. Yeah, I know. let's make a conf now. Wow, that took me way too long to make that, and I think that's still wrong. All right, let's make the conf. All right, test slash. For results, all basic, true. Make Certora is up to date. Oh, that's why. Do you always work 55 minutes with 10-minute break, or what's your schedule? It super depends. Oh, this shouldn't be in here. Oops. Certora run. Certora conf. What's the name of this? Oops. Verify option is in there. Must be formatted. Contract name, spec name, .spec. That makes sense. Conf. Where's that? Spec. Oh my god. Certora. Conf. No. Spec. Superhorse.spec. Good. Foundry Huff deployer not found. Oops. Because I need Foundry Huff lib. Okay. Hopped in late. Will this whole live stream be recorded and available elsewhere? It sure will be. It'll be available on my YouTube. Certora can't find this file, huh? I think I need FFI to be true. Oh, can Certora not? Ooh, I don't know if Certora can. So I'm using FFI to compile and deploy, and you know what? Certora probably doesn't know how to use FFI. That actually makes a lot of sense as to why I'm running into issues and why I've been running into issues, and that makes Huff a little tough to use here. I might have to not use Huff. That kind of sucks. I might have to write a ton of assembly instead of Huff for this. That might be kind of fun. Yeah, maybe I use Huff. Maybe I use assembly instead. Yeah, Certora compiles the code, and it's giving me this error, but I feel like it's... Yeah, okay, so I have to start over. Shit. Well, I think that makes a lot of sense. Why would it know? Why would it know, you know? Yeah, that's... I'm asking it to formally verify something that it's like, has... Yeah, that's ridiculous of me to expect that, actually. Let's leave those in there, just in case. The Certora compiler, yeah, does it identify remappings? I've not yet used it. It does. I think that error is a little misleading. I think the error really should just be, hey, what the hell is FFI? I think that's what's more likely happening. How difficult is it to refactor compiling and deployment to not use FFI? For what I want to do, basically impossible. Because I want Foundry to basically like know. I don't think Solidity allows inline assembly anymore. Couldn't it? Oh no, I could no, actually you're right. I would have no, it's not impossible. No, I'm being stupid. So what I would need to do is I would need to compile the Huff, copy paste the bytecode of the Huff into Solidity as like a storage variable, and then have my contract just deploy that. That just kind of sucks. Yeah, exactly. I could just take the compile runtime code and run tests on it. Yeah, I could do that. That just sucks though. I don't want to teach that. I don't think that's good for me to teach. So we're going to do something else. Yeah, we're going to do something else. Yeah, I think I want to play with this myself a little bit off stream, and then I'll come back. I'll probably stream some more tomorrow, but I also need to eat dinner. So yeah, but this is good. I figured out that Huff not gonna be so good. Not gonna be so good to use with Certora. I mean, I could use it. I could grab the compiled runtime code, as some of you all mentioned, stick that in the contract and call it a day, but I don't think I want to do that. I think I want to do something more seamless. Maybe I'll grab some inspiration for like Seaport or something to teach formal verification. I don't know. Well, in any case, thanks y'all for joining. Hope you had fun. Hope you learned a little bit. Let me know if I should or should not post Twitter Spaces about this in the future. And should I just like go live on YouTube? Is it annoying if I post on a Twitter Space that I'm live on YouTube? Let me know and I won't do that. But yeah, thanks y'all for coming. If you have any other questions, feel free to let me know. Live on Twitter at the same time. Love it. Thanks for all you do. Okay, cool. Oh, I should keep going live on Twitter? Okay, I can do that. I can definitely do that. Let's see how badly the Twitter algorithm punishes me for doing this. Cool. Have a great evening, y'all. Later. Good night.